question asks us to find the resultant force acting on the body, okay? Resultant force. So what you should do, you should quickly draw the free body diagram acting on this box here, okay? I draw the box in this place. So now, just take over this force, okay? Just draw the force passing through the center, okay? Passing through the center. Then, what other forces else acting? They must be the normal reaction force. What force else? It must be the weight, right? The weight, mg, okay? Now this is theta, so this angle also must be theta. So what we must do next, we need to resolve the forces to vertical and horizontal, right? But this is not the vertical and horizontal we want, because this box is accelerating along this direction, right? So we need to resolve all the forces along acceleration. So we need to resolve this along this direction and this perpendicular direction, okay? Now in this case, how do we resolve the mg along the acceleration? So this is the direction of acceleration, so this mg must be resolved along this direction, right? We need to resolve along this direction. So this is mg sine theta, okay? This mg sine theta. This direction is mg cosine theta, okay? Now what about this theta? This theta, this also theta, this theta. So this f again, you need to resolve along this direction and this direction. It must be resolving along the direction of acceleration. So f resolve along this direction, it must have this component, okay, this component, which is f cosine theta, because we are closing the angle. Remember, when close the angle is cosine theta, when open the angle is sine theta. For example, this case mg, how come I know immediately this is mg sine theta? Because I'm opening up this angle. I'm opening up this angle. Opening up become bigger, so it's become mg sine theta. Okay, I hope you understand that. Now what happens next? So this f, you forget to resolve. This is the direction you need to resolve. Okay, this one become f sine theta, right? Now in this case, we have already resolved all the forces to this own respective direction. Now we need to rub off those forces that is extra. So in this case, this mg I already resolved to this and this component, right? So immediately I need to rub off the mg, okay? I rub off the mg, otherwise we thought that there are three forces here. So this force f, we also have f cosine theta and f sine theta. Now we need to rub off the f because we already resolved the f, okay? Otherwise people thought that there will be three vectors acting, right? Okay, let me rub off properly. So now in this case, you know that all the direction of forces which is along these two perpendicular directions, right? So in this case, what is a resultant force? Resultant force must be acting along the acceleration direction. This is the direction we need to identify, okay? This is the direction we need to identify. So in this case, very simple, we just use F net equals to ma, right? This is the Newton's second law. So what is the F net? F net must be F cosine theta minus the mg sine theta equals to ma, right? So in this case, which is the answer? Which F cosine theta minus mg sine theta? That's why the answer is C. Oh, sorry, the answer is A.